Welcome back to the last video for day 5 of Unit 9A. We're looking at arcs and chords, and we've talked about 3 properties. The first one is if 2 chords are congruent, then their arcs are congruent, and the converse works. If the arcs are congruent, then the chords are congruent. The second one says if a diameter hits a chord at a 90-degree angle, then it divides the chord in half and the arc in half. The converse also works. If you see that one chord is dividing another chord in half and the arc in half, then we know that that chord is a diameter and it's perpendicular to it. Okay? The last property we talked about in this lesson is that if 2 chords are equal, then they are the same distance perpendicularly to the center. And it works vice versa. If they're the same distance from the center, then the chords are equal. So all the converses also hold true today. And we've already done 3 examples. Let's do a few more. In circle Y, the radius is 34. Now if I look at this picture, there's no radii drawn in. So I can draw in a radius, and I can draw it anywhere I want, but it makes most sense. Well, I do have one radius, but it's kind of awkward to draw it because it's intersecting something. So it's easier to draw a radius that's not intersecting something. And so I would recommend either drawing the radius to A or drawing the radius to B. We can draw it to either one. It doesn't really matter. I'm going to go ahead and draw it towards A. Doesn't really matter. Okay. So my radius, it says, is 34. So I'm just adding that to the picture. AB is 60, so this whole thing is 60. Okay. So now I'm going to use that second property that said, because I see this 90-degree angle, and I see part of a diameter that's hitting at a 90-degree angle. So I know this chord is being divided in half. So if AB is 60, that means this piece here is 30, and this piece here is 30. It also means that this chord is divided into 2 equal pieces. Arc AC is 71. So this side here is 71, and I also know that this side is 71. So that's everything I got just by reading the prompt. Again, that's why it's so important to make sure you read these prompts. And if you can't print out your assessments or your notes, I would definitely use scratch paper to be able to draw these circles. Okay? All right, so now let's see what these questions are asking me for. The first one says to find the measure of arc BC. So arc BC, I can see I've already written it down, so it's easy. It is just 71, and since it's a measure of an arc, it is degrees. Okay? YD. Now for YD, it's real tempting to go, okay, my radius Y to C is 34, so these two, this must be 17 and this must be 17. However, we've not said anything about the radius being bisected by a chord. That wasn't any of our properties today. Okay? But if I want to find YD, I can figure that out because I have this little right triangle where I know the hypotenuse is 34, one of the legs is 30, and I want to find the other leg. So that means inside my square root, I'm going to subtract. 34 and 30, my bigger number is 34, so I'm going to square that one to find out how long, square both of them, to figure out how long my Y to D is. So 34 squared is 1156 minus 30 squared is 900. So that is the square root of 1156 minus 900. That's 256. The square root of 256 is 16. And we don't have any units, so I'm just going to say units. So this piece here is 16, which means this piece here, 34 minus 16, is actually 18. So we would have gotten 17 if we just divided the radius in half, and we would have been wrong because it's not dividing that radius exactly in half. Okay? Oh, look, I accidentally did number 6 already. Number 6 was saying, well, how long is DC? Oh, I already did it. right? If I know the whole radius is 34 and this piece was 16 because we did Pythagorean theorem, then what's left has to be the whole radius, 34, minus this piece of the radius, 16, which gives me that 18 units. So I had already done that one. I just kind of did it on accident. Okay. All right, let's look at number 7. For number 7, the measure of arc AC. When I look at this figure, the first thing I notice is I have 2 chords that are the same. That means I have 2 arcs that are the same. So both of these arcs are the same. I've used 90 degrees here. There's 360 degrees in the whole circle. I've already used 90. That leaves me with 270 degrees left for the rest of the circle. And that's divided into 2 equal arcs. So I'm going to take my 270 and I'm going to divide that in half, which is going to give me 135 degrees for this side and this side. So that these 2 arcs are the same, and all 3 arcs together, all the way around that circle, is 360 degrees. So the measure of arc AC is 135 degrees. Okay, and then the last one. The last one I have here, I have this circle where I can see this arc is congruent to this arc. That means the chord that intersects those arcs are equal. So this 2x plus 4 must be equal to the 18. All right, that's all the geometry involved in this problem. The rest is algebra. Minus 4. 2x plus 0 is 2x equals 14. Divide by 2. 2x over 2 is 1x. 14 over 2 is 7. And we're going to say these are just, we don't know what kind of units they are. 7 units. Okay? All right, so again, we used our 3 properties. The first one, congruent arcs have congruent chords, or congruent chords have congruent arcs. The second one, a diameter that's perpendicular to a chord bisects the chord in the arcs. Or if if a chord is bisected and its corresponding arc is bisected, then the chord that goes through it is a diameter, okay, at perpendicular angle. And then the last one, congruent chords are equidistant from the center. Or if 2 chords are equidistant from the center, then the chords are congruent. Okay? If you have any questions about any of these types of problems or any of these 3 properties of chords and circles, please make sure that you attend tutoring or sync time and ask your teacher. All right? Thank you so much for watching.